Yes, thank you very much, students. In today's teaching, we are going to study about the large samples. Okay, we know that were large samples. Can you recall what is a large sample? If the size of the sample, that is n, is greater than 30, it is called large samples. Am I correct? So in this particular large samples, what we are going to study is about the difference of two proportions. That's what we are going to study now. Okay, so what's the meaning of that? Now let us take, or I can take this. This is one population, this is another population. Suppose I can say that, suppose the how can I say that? I can say this so that I can rub this. Suppose that the population, the proportion of this particular population is capital P1, suppose, and the proportion of this population is capital P2. So our question is that whether these two populations are equal, that is, there is no significant difference between these two populations, or there is a significant difference between the two populations. Whether this proportion is completely different from this proportion, or this proportion is very close to this. That's what we are interested in. Okay, for that, what we are doing is that we are taking some samples from this. Suppose that it is n1 size of the samples whose proportion is P1, and we are taking another samples from this. Suppose that sample size is n2 and the proportion is P2. By connecting these two, we will have a statistical formula. Will have, by connecting these two samples, okay, and then we will get the statistical value and the tabular value. We are comparing them. If the calculated value is less than the tabular value, then H0 is accepted. H0 is what? The null hypothesis. With that in mind, I am going to take one problem and I am going to solve it. Okay, can we do that now? Let me erase all those things. Okay, so before that we must know what is the formula, the statistical formula to test the test of significance for two proportions. Two proportions means two population proportions. Okay, the formula is given by P1. It is not good, so somewhat big one, so I have to make it a small one, right? P1, small p1, minus small p2, divide by a square root of PQ, capital PQ, into 1 by n1 plus 1 by n2, and all these should come inside this bracket. And this is what test statistic to test the significance of two different proportions. Okay, so this is what we have to calculate, and this particular formula will come over here, and we have to calculate. All the data will be given to us. P1 is the proportion of the first sample, P2 is the proportion of the second sample, N1 is the size of the first sample, N2 is the size of the second sample. Okay, to understand more, let me take suppose that this is one population and another one is another population here. Okay, and the sample we are taking, from that we are taking the samples. Suppose the sample size here is N1, is the size of the first sample, and its proportion is small p1, and we are taking another sample from the second population whose sample proportion is p2 and the size of the sample is N2. So this is what we are seeing here. P1 is this one and P2 is this one, N1 is from here and N2 is from here. Okay, now what about that P, capital P? Then what is capital P and capital Q? Capital P and capital Q, that I will explain you now. It is coming from the formula. Look at the formula now. The formula I will tell you. The formula is that P, where P is some formulas. Now I have to rub this, and what is that P then? Okay, P formula is nothing but N1 P1, the size of the first sample, multiplied by the proportion of the first sample, plus size of the second sample N2, multiplied by the second proportion P2, divided by the sum of the size of the two samples N1 and N2. This is what the capital P, what is coming here, this is capital P. Okay, just you are multiplying the size of the first sample by the proportion of the first sample plus the size of the second sample plus the proportion of the second sample, add both of them, divide by the sum of the size of the two samples, that is capital P. Okay, now what is Q then? Okay, so Q is nothing but 1 minus P, and here what's the Q coming here is equal to 1 minus capital P. What is this P? This P is coming from this P, that P. So P can be calculated by using this particular formula. Q can be calculated for this particular formula. P1, P2 we know, N1, N2 we know, and then we are substituting all those values here in that particular statistical formula to test the significance of the two proportions we can find out. Okay, now let us discuss about the problem given to us. Okay, what's the problem? In Coimbatore, 20% of a random sample of 900 women have corona symptoms. So in Coimbatore city, 900 women were taken, and out of them 20% have corona symptoms. This is the first point given to us. What is the second point? In Salem, 18.5% of random sample of 1600 women had the same problem. Same problem means corona problem. So out of 1600 women, 18.5% of people affected by the corona symptoms. Now the question is the difference between the proportion significant? The meaning is that we have to check whether the proportion of the corona affected people in Coimbatore, that is the proportion of corona affected people in Coimbatore and corona affected people in Salem, whether the both proportions are equal or not. I will explain you here by taking a good example. Okay, now what is this? This is Coimbatore, and this is what? Salem. Samples taken, and from the sample here given there 900 people taken from Coimbatore, right? 900 people, when taken 20% of them, 20%, okay, this proportion people affected by corona in Coimbatore. And another one, Salem is given. From the Salem, what we understand, how many people have taken? 1,600 people were taken, and out of them 18.5% 5% were affected by corona. So what is given to us? P2 is given as 18.5 and N2 is given the size of the second sample. Here what is given to us is N1 is given to us, and that is equal to 900, and P1 is given, that is proportion of the samples given 20%. Okay, so what is the question here is, if the sample data is like this is a sample data given to us, if this is the portion, then can we say that the proportion Coimbatore and Salem are equal? Proportion of the corona affected people in Coimbatore and Salem are equal or not? Okay, so I am assuming that P1 is the proportion affected by corona in Coimbatore, P2 is corona affected people in Salem. Okay, now the question is whether P1 is equal to P2 or P1 is not equal to P2. P1 is very close to P2 or P1 is not very close to P2. That's what we need to understand here. So for that, let me discuss how to get the answer. Okay, now let me take the problem, then we will discuss about that. Otherwise we can take this and we will rub that. Sorry, in here it is and 2. Okay, now as usually what are given here is that N1 is given to us. How much is that N1? N1 is the total sample size, 900. Okay, right, and N2 is also given. How much? 1,600 given to us. 1,600 given to us, that is 106,000 people were taken, and they were 18.5% affected. Now what is P1? P1 is 20%. P1 equals 20%. I mean 20%, how can I write as 0.2? I can write 20% means 0. And what about the Salem proportion? proportion of corona affected people is 18.5%. How can I write 0.185 as 0.185? So P1 given, P2 given, N1 given, N2 given. How can we find out? So we can substitute P1 here, we can substitute P2 here, we can substitute N1 here, we can substitute N2 here. But we need to find out what is a capital P, what is capital Q. Those things we have to find out. Okay, so let us find out what is the capital P here. Okay, now we know already what is capital P. I told you already, am I correct? So capital P is equal to, I told you already, N1 P1 and plus N2 P2 divided by N1 plus N2. That's what the capital P formula. All data we know well here, am I correct? So this N1 you substitute here, and P1 you substitute here, N2 you substitute here, and P2 you substitute here, N1 you substitute here, N2 you substitute here. Finally, what you will get for this answer, I am writing here, the answer for this is equal to 0.1904. 0.1904 0.1904. So that's what we get P here. Okay, so P we have got the value as where can I write here? Capital P equals 0.1904 1904. Here 9, it is 9. So we have got the P value. Now what is Q? I told you that the formula for Q is equal to Q, capital Q equals 1 minus P. Capital P equals 1 minus P. That is 1 minus, what is P here? 0.1904. 0.1904. So if we substitute that, the answer would be 0.8096. The answer would be 0.8096. 8096. That's what we get there. So actually the value of Q, capital Q, would be equal to 0.8096. 8096. Okay, 8096. Okay, so I am rubbing all these things because these and all not needed for us. Am I correct? And these also we have got the answer for that. So I am rubbing up. Okay, come to the problem now. The problem is that this one, am I correct? Yeah. Therefore, we have got all components. What we have to find out. Okay. Now let us start with the null hypothesis. What is null hypothesis here? Is that we are assuming that the proportion in Coimbatore as well as in Salem are equal. The proportion of the corona affected women's in Salem and Coimbatore are equal. That's what our null hypothesis. Okay. Now capital P1. Now look at the screen here. That is what. Now this is Coimbatore. This is Salem. I am assuming that this is the proportion of Coimbatore. P2 is the proportion in Salem. Now I assume that there is no significant difference between the proportions in Coimbatore and in Salem. So both of them are the two populations. Am I correct? So I am taking P1 is the population of Coimbatore and P2 the population of Salem. Now I suppose that there is no significant difference between these two, therefore I am taking as equal. So this is called null hypothesis. I was explaining already to you. Am I correct? So null hypothesis I am taking as here P1 equals P2. Okay, P1 equals P2. Capital P1, that is population proportion in Coimbatore is exactly equal to population proportion in Salem. That is the proportion of corona affected people in Coimbatore, and this is what a capital P, not small p, is a capital P. That's very important thing you have to understand. So corona affected people in Salem, P, capital P2. So this is null hypothesis. Now what is alternative hypothesis here? I already told you that the opposite of the null hypothesis is alternative hypothesis. Here the two proportion of corona affected women are equal. So the alternative hypothesis that the proportions in the two cities are not equal. The proportion of affected people in the two cities are not equal. So this is what we say an alternative hypothesis. Okay. So alternative hypothesis we have got. Now next step, already we know that the calculation of test statistics. That's the next step. Am I correct? We know that what is a test statistics. Look at that at the top. This is a test statistics to test the significance of two proportions in the populations. Okay, so we have to substitute all the values of P1. What is P1? 0.2. P2, what is P2? 0.185. What is P? P is equal to 0.1904. What is Q? Q is equal to 0.8906. What is N1? Size of the first samples 900. What is N2? Size of the second sample 1600. Okay, so all these values, these values you have to substitute here. Okay, all these values you substitute here, and that will give you the calculation of test statistics value. Okay, so just you take this and N1 you substitute here, N2 you substitute here, and P1 you substitute there, and P2 you substitute here, and capital P capital P you substitute here, and capital Q has that here, and that you substitute here. Okay, so if you substitute all these things in this above statistical formula, and then you substitute, and can you give me the answer for that? What is the final answer for this when you are substituting these values in the formula? Okay, you just substitute and tell. Okay, you do that and check whether my answer is correct or not. Okay, the final answer would be equal to 0.92. You have to get the value of the test statistic, that is calculated value of test statistics is that is Z. Calculated value of Z would be equal to 0.92. so if you calculate here, what you are going to get is that 0.92. you are going to get 0.92. that's what you are going to get that. Okay, 0.92. that is what I am writing here, 0.92. That is what step number 2. So calculated value of this normal variate Z equals 0.92. Now let us calculate the table value for this particular statistics. Okay, so what we have to do is that we have to go to Z table, that is normal table. Z table value, the normal table value you have to go. Then suppose the significance I am taking as 5%. Okay, 5% level of significance I am taking, and it is two-tailed test. Am I correct? Because the alternative hypothesis we are taking as P1 is not equal to P2. Look at that. Look at this. You will get that. The alternative hypothesis here. Look at that here. The alternative hypothesis here we have taken as P1 is not equal to P2. Therefore, it gives you a two-tailed test. Am I correct? A two-tailed test. That's what we have to get. So here, for two-tailed test, for two-tailed test, two-tail. Now look at that. Now look at that. We have the table nearby for two-tailed test. For two-tailed test, 5% level of significance, that is 1.96. now look at that. 1.96 is the 5% level of significance. The two-tailed test, the value is 1.96. Am I correct? So 1.96, the value here is equal to 1.96. Yeah, so the calculated value we have got, and the table value here, that is ZT, that is what table value we say. So ZT is equal to 1.96. Now what is the next step? Usually the comparison of the calculated value and the tabular value. That's what the next step. So here the calculated value we know well here. What is the calculated value? Here the calculated value is that ZC. The calculated value is 0.92. 0.92, and then table value is given here. That is the table value of Z here in our case is equal to 1.96. Now I am comparing both of them. What I see is that the calculated value of the Z variate is less than the table value of Z, that is 1.96. Calculated value of Z variate is 0.92, whereas table value of Z is equal to 1.96. So this value, calculated value, is less than the table value. That's what we are seeing here. Am I correct? Calculated value is less than the table value. That's what I am seeing here. Am I correct? Yes. So already I told you that if this is the case, H0 should be accepted. So if this is the case, that is this side is less than this side, then what is our answer? Our answer is that H0 should be accepted. That's what our case. Am I correct? So H0 is accepted. H0 is accepted. What's the meaning of this? Accepted. What's the meaning here? Is that the null hypothesis we have to accept. What's null hypothesis we have assumed here? The null hypothesis, look at that. So what is the null hypothesis we have assumed here is that the proportion of the corona affected women in Coimbatore and Salem are equal. That's what we have assumed, and that is what we have taken as the null hypothesis. Am I correct? So H0 is accepted implies that proportion of corona affected women in Coimbatore, that is P1, and in Salem are equal, or there is no significant difference between the P1 and P2. Okay, so there is no, that's what we have to write here, and the final answer is that there is no, because that will give you the conclusion for our question. Okay, so there is no significant difference. There is no significant difference. Significant difference means what? The significant difference between the proportions of corona affected people in Coimbatore and in Salem. So the proportions are equal. There is no significant difference. That's what our conclusion. Okay, so this is what the problem about. I repeat again in a very short words. The given problem is Coimbatore, 900 people or women have taken and checked, and they were affected by corona symptoms. Out of them, 20% were affected. Out of 900, 20% were affected by corona. Okay, right. Then outwards, Salem. In the Salem, how many sample size? 1600 women were taken, and out of them 18.5 were affected by corona. So these were the samples given to us. Our problem here is that we must talk about the proportions in Coimbatore, in Salem. So we assume that the proportion Coimbatore and Salem are equal. This is a null hypothesis. The alternative hypothesis P1 is not equal to P2. Then we are using test statistics. By using this particular formula, we are finding out test statistic value, that is calculated value equals 0.92. Then afterwards, calculation of the table. For that we have to refer the Z table. For 5% we assume here for two-tail test, because here see the alternative hypothesis we are here, that is P1 is not equal to P2. That gives you two-tail test. Now we are seeing the normal table here. For two-tail test, 5%, the critical value is 1.96. So the table value for the given situation is 1.96. Now we are comparing the calculated value and table value. Calculated value is 0.92, table value is 1.96. Therefore the calculated value is less than table value. The last step is that conclusion step. So if this is the case, H0 is accepted. H0 means what? Null hypothesis. What's null hypothesis? At the beginning we have taken is that the proportion of corona affected women in Coimbatore and as well as in Salem are equal. Otherwise we can say that there is no significant difference between corona affected people in the population of Coimbatore and the another population of Salem. So finally we got that there is no significant difference between the two proportions of corona affected people in Coimbatore as well as Salem. So thus we come to the end of this particular problem. In another video I will take another situations we will discuss. Thank you.